Welcome to the Astro Guy podcast. In this episode, we're going to take a look at what's going on with the planets in June of 2023, and we're going to take a tour and see some of the best deep sky objects that June evenings have to offer. Stick around and enjoy. Welcome to the Astro Guy podcast. I'm not an expert, I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem, seize the night. I'm your host, Wayne Zool, and this is the Astro Guy podcast. June is here, and that brings warm weather and shorter evenings for those of us in the Northern Hemisphere. On June 21st, the sun will reach the summer solstice, reaching its furthest point north for the year. The longest amount of daylight is observed on this day, as well as the shortest amount of daylight in the Southern Hemisphere. From June 21st until the December solstice, the days will continue to get shorter and shorter. The planets, however, are putting on a nice show this month in both the evening and the morning skies. Unfortunately, Mercury is lost in the glow of the sun all month. But Venus is again the showstopper in the evening skies. Enjoy it now, because by the middle of July, Venus too will get lost in the glare of the sun before returning to the morning skies. At 9 p.m. on June 1st, Venus is about 30 degrees above the western horizon. It's easy to spot as it's shining at magnitude minus 4.4. The disk of the planet is 51% illuminated, and it spans about 23 arc seconds in diameter. As the month goes on, Venus gets brighter, reaching magnitude minus 4.7 by month's end. As Earth and Venus get nearer in their orbits, Venus appears to grow to 33 arc seconds by the end of the month, although the crescent will shrink to only 32% illuminated. This is a great time to see Venus. About 30 minutes after sunset, it should be easy to spot in the western sky. Binoculars can help you pick it out of the twilight. In a telescope, you'll easily see the phase of the planet, and under proper conditions with a violet filter, you might be able to make out some of the cloud structures in Venus's atmosphere. Regardless of what you're using, just get out there and see Venus in all its glory. Mars is also visible in the western skies on June evenings. Much fainter than Venus at magnitude 1.6, its reddish-orange color and lack of twinkling makes it easy to spot once it's dark. Mars will be in the evening skies over the next few months, while it eases toward a conjunction with the Sun in November. However, it's small and will be getting dimmer and closer to the horizon until then. In a telescope, Mars appears small, spanning only about 5 arc seconds across. But if the atmospheric seeing is decent, you should still be able to make out some markings on the planet. Give it a shot now, as Mars won't be getting better in our skies until 2024. On June 1st, 2nd, and 3rd, using binoculars or a telescope at low power, you should be able to spot Mars and the Beehive cluster, M44, in the same field of view. Jupiter can be spotted about 8 degrees above the eastern horizon on June 1st, about an hour before sunrise. As the month goes on, the giant planet rises a little earlier each day. By the end of June, Jupiter will be about 27 degrees above the eastern horizon 1 hour before sunrise. It's easy to spot. Shining brightly at magnitude minus 2.2, Jupiter spans about 35 arc seconds across, and through binoculars, the disk of the planet is easy to spot, as are the 4 Galilean moons. In a telescope, you should be able to spot the colorful, although muted equatorial bands, and when it's facing us, the Great Red Spot. On the morning of June 14th, the 14% waning crescent moon will be a mere 2 degrees northwest of Jupiter. This should be an amazing sight to see that morning. As June begins, Saturn rises around 1:30 a.m., and is very well placed for observing in the hours before sunrise. By the end of June, the ring planet will be rising before midnight. Saturn spends the entire month in the constellation Aquarius. Yellowish Saturn shines at magnitude 0.8, and the disk of the ring planet is about 17 arcseconds across. On the morning of June 10th, try to spot Saturn, as it will be about 6.5 degrees west of the waning gibbous moon. Uranus is lost in the glare of the sun all month long. Spending all of June in Pisces, magnitude 7.8 Neptune rises about 2:15 on June 1st, and just after midnight by the end of the month. Neptune is small, spanning only about 2.5 arcseconds across. You'll need a telescope with some magnification to even make out the bluish-green disk of the planet. In June, unfortunately, there are no significant meteor showers for us to see. Before moving on to our tour of deep sky objects for this month, I want to remind you to check out the upcoming episode, where I had the pleasure of interviewing 3 gentlemen who in 2022 each attended their 50th Stellafane convention. This is a great opportunity to learn about the oldest and most famous amateur telescope-making convention in the world. Later this year, the Springfield Telescope Makers will honor the 100th anniversary of the first annual convention, so this will be a fun and informative episode. Make sure to check it out. Moving on to our tour, we're going to highlight some of the best deep sky objects that are visible each month, as opposed to exploring 1 or 2 constellations. The objects will be visible in the evening skies. Most will be visible in binoculars or small telescopes. Let us know if you like this format. We'll begin this month's tour in the constellation Coma Berenices as we explore the Edge-on Galaxy NGC 4565, which is referred to as the Needle Galaxy. This is the faintest object that we'll explore this month, so you could say that we're starting with a challenge, but it's actually not that difficult to spot. Listed at magnitude 12.4, the galaxy spans about 15 by 2 arc minutes. Its length is about half that of the full moon. The Needle Galaxy is located about 47 million light-years away from us. Classified as a spiral galaxy, we see the needle practically edge-on, giving the galaxy its name. I have spotted this galaxy in a 70mm refractor, but it looks best in at least a 6-inch or larger telescope, where you should be able to spot the dark dust lane that bisects the galaxy. To locate the needle, begin at the star Cor Caroli and sweep 11 degrees south, and you'll come to a 5th and 6th magnitude star that are separated by about half a degree. Now, sweep east from the fainter star about 2.5 degrees, and then sweep 1.5 degrees south, and you should see the needle in your eyepiece. A bit brighter is the Sunflower Galaxy, M63, in the nearby constellation Canis Venatici. Listed at magnitude 8.5, this galaxy spans about 12 by 7 arc minutes. The core of the galaxy is well concentrated and can be spotted in binoculars from a dark sky location. Best viewed through a telescope, the core and the inner spiral arms should reveal themselves as a mottled cloud surrounding the core of the galaxy. The Sunflower is located about 37 million light-years away from us. To locate M63, start at Cor Caroli and sweep just north of east about 4 degrees, where you should spot 2 4th magnitude stars. Now sweep north about 1.5 degrees and you should spot the galaxy. Maybe you're not really that into observing galaxies and globular clusters are more your thing. Well, June evenings will not disappoint. M3 in Canis Venatici is one of the finest examples of a globular cluster in the entire night sky. If it weren't so near the more famous M13 in Hercules, this cluster would likely be even more revered by observers. Situated about 34,000 light-years away from us, this cluster of very old stars spans more than 180 light-years across. The member stars are estimated to be more than 11 billion years old, and there are more than 500,000 member stars. The cluster spans about 18 arc minutes in size and glows at magnitude 6.3. From a very dark sky, you might just be able to spot it with the naked eye. Binoculars will make finding it pretty easy. In binoculars, the cluster appears as a faint cotton ball, brighter in the center and fading as you look outwards. To locate M3, start at the bright star Arcturus in Boötes and sweep towards Cor Caroli. About 12 degrees along that line, you'll spot M3. Likely, this will become one of your favorite objects for spring and summer evenings. Next, we'll visit the Great Cluster in Hercules, the famous globular cluster M13. From a dark sky location, you can spot this cluster with the naked eye, and with binoculars, you'll even be able to start resolving a few of the stars within the cluster. In a telescope, you'll really be able to enjoy it, as hundreds of member stars can be resolved. The cluster spans about 20 arc minutes in size and glows at magnitude 5.8. It's made up of between 300 and 500,000 stars, and the cluster spans about 145 light years across. It's also a bit closer to us than M3 at a distance of 22,000 light years away. Locating M13 is just easy. Start at the brightest star in the keystone of Hercules, Retilicus. Now sweep north just about 6 degrees and you'll see the cluster. Our last two objects this month are a pair of globular clusters in the constellation Ophiuchus. We're highlighting them last as they appear better later in the evening. The pair are separated by about 3 degrees, and you can see both of them in the same binocular field. Let's look at the brighter of the pair, M10. Shining at magnitude 6.4 and spanning 20 arc minutes, although visually it appears about half that diameter, M10 is a beautiful globular cluster to observe. It's located about 14,000 light years away from us and contains several 100,000 stars. In binoculars, it appears as a small fuzzy patch, while in a telescope you can begin to resolve some of the member stars. M10 is pretty easy to find. Start at the magnitude 2.4 star Sabak, or Eta Ophiuchi, and sweep north about 11.5 degrees. Then sweep west about 3 degrees, and you should see the cluster. Situated about 3 degrees northwest of M10 lies M12. This globular is a bit smaller and fainter than its neighbor, but once you find M10, it's easy to spot M12. M12 glows at magnitude 7.6 and spans about 16 arc minutes in size. Located about 16,000 light years away from us, it is about 75 light years across. As far as globular clusters go, M12 is not as tightly packed as most of them, and originally it was thought to be a dense, open cluster, although we have learned that that is not the case. In binoculars, you should see the cluster as a small, relatively faint, fuzzy patch. A telescope will show the shape of the cluster, and as you boost the magnification and with higher apertures, you should be able to resolve some of the member stars within the cluster. Hopefully, these objects will become favorites for you as well. Well, that's all for this episode. Thank you so much for tuning in, and I hope that you've found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a text or a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy podcast group on Facebook. You'll find other members, videos, blogs, and other useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Please subscribe. Please consider leaving us a review on your podcast platform. It helps us to get new listeners. Thank you again for listening, and may your skies be clear. As always, Carpe Noctem. Seize the night. I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.